Hello everyone. So today we are going to solve one previous year question in JEE Mains asked in the same year to 2026. This question is actually from electrostat and based on the concept of potential. So the question is saying that there are three concentric conducting spherical cell. We have three spherical conducting cell and they all of them are concentric, means they have same center. A, B, and C of radii A, B, and C respectively, and they are charged with charge Q1, Q2, and Q3 respectively. The potential of the sphere A, B, and C respectively are. So, what will be the potential of all those three surfaces? Before we go into the question, first of all, we would like to discuss how does potential vary in a sphere. Let's suppose that we have a spherical cell, conducting spherical cell. Here it is already written conducting spherical cell, means charge will stay on the surface. Suppose that we give it some positive charge. So charge will stay on the surface. Now if we define 3 points, first point, okay, let's suppose that this is a center C. First point we take this one P1. Second point we take exactly on the surface of the conducting cell or conducting sphere. It will be P2. And third point we are taking here, it is P3. So suppose that this distance is R. Call it R1. This distance is R2 and this distance is R3. Radius of the cell is capital R. Now when we'll write potential at all 3 points, inside, outside, and on the surface, first of all, we can write V is equal to, first of all, inside. So inside the spherical cell or inside conducting sphere, because either it is spherical cell or conducting sphere, in both case charge will only reside at the surface. So if this is a conducting sphere or spherical cell, whether it is conducting or non-conducting, in the case of cell, the charge will reside on the surface, and inside the spherical cell the potential will remain constant. Inside potential will be same, and the potential is going to be K Q. If we have given this surface of this cell charge Q, then Q divided by capital R, which is radius of this cell. So KQ by R. When point is inside the cell, means R, which distance we have taken, R is equal to, not equal to, actually it will be less than, R is less than R. Means when the point is inside, means we are taking here actually R1 distance. When point is inside, then potential is just KQ by R. R is radius of the sphere or radius of the cell, not distance of, means we are not taking the value of R1. Here will not take R1. Why? Because it will not important where point P1 is. If the point is inside the cell, the potential will remain constant, and that's why the electric field inside cell is zero. Wherever potential is zero, potential will remain same, electric field will remain zero, because electric field is only exist when potential changes. So inside the cell potential will remain constant and electric field will be zero. If we go at the surface, surface is exactly at a distance r from the center. So here also potential will remain same, kq by r. So we can add here equal to sign. So for inside the cell and at the surface of cell, potential due to the charge q given to the same cell will be kq by r. Now if we go outside, let's take this distance only r, not rq. Now potential here is going to be k q by small r, where r is the distance of this point P3 from the center C. Here the distance will start to matter. Inside the cell, where position 1, I mean where point 1 was located is not important, because expression is just kq by capital R. R is radius. But when we go outside the cell or outside the sphere, then position of this point will become important. At what distance this P3 point is located? If it is located at a distance small r, then potential there will be kq by small r. So for r greater than capital R, where r is the distance of point from the center of the cell. Here this r, small r, all three small r is the distance of point from the spherical cell. Now using the same concept, we are going to solve this problem. Here they have seen, they are saying that we have three concentric sphere. So let's make first three concentric sphere. It became ellipse. We want sphere 1, 2, 3. These are three conducting spherical cell. This cell name is A, this cell name is B, and this cell name is C. Similarly, their radius is also, this is A, this will be B, sorry, actually this is C, their third is C, and this is going to be B, B, A, B, C. If possible, let me clear this. So radius of all three concentric cells are A, B, and C, and they have given a charge Q1 to this, Q2 to this, and Q3 to this. Now they are asking what will be potential at surface A, B, and C. So let's calculate first of all potential at A. First of all, we will calculate potential at A. At A, at A. So potential at A, when you will take a point on the surface of A, for this sphere, means for inside, let's write here VA. For the first sphere whose radius is A1, or we call for the cell A, this point lies on the surface of the cell A itself, and charge given is Q1. So it will be simply K Q1 divided by, it is lying on the surface, so it will be radius of this small, remember here, when it lies on the surface, potential is K into Q by radius of the cell. So here radius of the cell is A1. So A1. Now this point is inside the second cell whose name is B. This same point is inside the cell B. So this point will also have some potential due to cell B, and this point which actually we are discussing about, this point P1. This point P1 lies inside B, not outside B, inside B. And we all know inside B or inside any sphere or inside any cell, conducting sphere or cell, potential remain constant, and it is also plus K, charge given to B is Q2, and divide by radius of the B, because we are considering point inside B, so radius of the B, so it will be A1 then A2. In the question they have taken radius as ABC. Yes, by mistake I have taken A1, A2, A3. No, we have taken ABC. Fine. Here I am doing mistake. This is B. This would also be just A. So potential at P1 due to B, I mean due to charge on B, will be K into A2 plus B, plus again this point P1 is also inside C. So due to this, potential will be KQ3 divided by C simply. So potential at A is going to be this one. Similarly, when we'll write potential at B, at any point at B, suppose that we take this point, call it P2. So at B, potential is going to be, see, point P2 is outside the innermost cell, which we call A. Cell A, point P2 is outside cell A. And when it is outside, here potential will be K, Q, Q1, because we are calculating potential for this cell A, divided by distance of this point from the center, because now P2 point is outside this innermost spherical cell. So we have to take exact distance. If P2 is inside the inner cell A, then we'll take radius of A, but it is outside cell A. So we have to take distance of P2, and we all know distance of P2 from the center will be B. Plus, for cell B, the point itself lies on its surface, so it will be K Q2 by B, and plus for C, it is inside, so again it will remain same, and it will be K Q3 divided by C, just like first one. Now when we'll calculate potential at C, so potential at C is going to be, now for if we take any point on C, let's call P3 point, then P3 is outside cell A as well as outside cell B. And whenever point is outside, so whether we calculate potential due to A or potential due to B, it will be taken as distance of P3, means point 3 from the center of these two cell A as well as cell B. And we all know both the cells have same center here at O. Let's call the center as O. Now Vc will be K into Q1. Q1 is the charge on A and divided by distance of P3 from center, which is A, plus K into charge on B. When we will calculate potential due to cell B at P3, it will be K into Q2 and divided by distance of point P3 from the center, which is C. Actually, this is also C. Sorry for the mistake, not A, but this is also C. So, distance of P3 from the center of innermost cell is also C, and plus. Now for cell C, the point P3 itself lies on its own surface. So potential will be K into its charge Q3 and divided by radius of this outermost cell, which is C. Now when you will write, see, this will remain same, VA KQ1 by A plus Q2 by V plus KQ3 by C. But when we write potential at B, we can write in short that, I mean, just I'm taking common, K common, so Q1 by Q1 plus Q2 divided by B and plus Q3 divided by C. Similarly, when we will write for VC, we can write K common, Q1 plus Q2 plus Q3 and divide by C. So now let's choose the correct option. Which one of them is correct? C, option D. K they have written 1 by 4 pi epsilon naught Q1 by A plus Q2 by B plus Q3 by C. 1 by 4 for B it will be Q1 plus Q2 by B plus Q3 by C, and for C Q1 plus Q2 plus Q3 by C, and whole everywhere whole multiplied by 1 by 4 pi epsilon naught. So remember the concept. When point is inside, potential is kq by radius of the cell. Even if point is on the surface, kq by radius of the cell. But when point is outside, then distance of the point will start to matter. I hope you understand this. Keep watching, keep learning. Thank you.